Factor by grouping. After watching this video, I will be able to factor a quadratic expression by grouping. Okay, so you should have already watched a lesson video on factoring using the greatest common factor. And essentially this is the same thing, but this is called factor by grouping because there is no greatest common factor for every single term in the polynomial. And what we're going to do to kind of bypass that is we are going to group terms together. So I'm going to take the first two terms and I'm going to group those things together. And then I'm going to take the second two terms and group those together. So I'm going to work them individually. So if I just focus on my red parentheses or whatever is underlined in red, I'm going to factor out a GCF. So I'm going to factor out the number 5 and b squared, and I'm going to see what's left over when I divide by my greatest common factor. So 25 divided by 5 gives me 5. B to the third power divided by b squared. Keep the base, subtract exponents, which just gives me 1. Negative 30 divided by 5 gives me negative 6. B squared divided by b squared, they both cancel out. And now I'm going to do the same thing with my blue portion. So I have negative 20b plus 24, and I'm going to see what is the highest GCF I can factor out. Now here is the catch. My goal is that I end up with the same 5b minus 6 in my other parentheses. So I'm going to factor out a positive 4. And I'm going to see what's left over. So negative 20 divided by 4 gives me a negative 5b. 24 divided by 4 gives me a positive 6. I do not have the same thing as I do in my first parentheses, but it's pretty close. I just need it to be its opposite. So if I would have divided by or factored out a negative 4 as opposed to the positive 4, that would have changed my inside. So negative 20 divided by negative 4 gives me a positive 5b. And then 24 divided by negative 4 gives me a negative 6. And now my two parentheses are alike. And the reason I want to do that is because I essentially want to factor out another common factor. Well, these are common because they are exactly the same. So I'm just going to write that as one term. So 5b minus 6. No need to write it twice. And then I'm just going to write whatever is left over. So 5b squared, and then there is a minus 4 left over. And I'm just going to write those in parentheses. So this is a factored form of my large polynomial. If I wanted to check my work, I can multiply everything out and I would end up back at my original. So now you try. Factor this polynomial completely. So your first goal is to group the first two terms, group the last two terms. And then I'm going to factor using a GCF. So the greatest GCF I can get in terms of numbers is 7 and then an a squared. And I'm going to see what's left over. So 35 divided by 7 is 5. A squared divided a to the third power divided by a squared is just a. 42 divided by 7 is positive 6. And now I'm going to factor out my other two terms. So I'm going to factor out a 3. And I'm going to make that negative 3 because I see that I need to have a positive 5a. So if I factor out a negative 3, I'm going to see what's left over. So negative 15 divided by negative 3 gives me a positive 5a. Negative 18 divided by negative 3 gives me a positive 6. And this works because I end up with 5a plus 6 in both of my parentheses. So that is a common term. And then I'm going to factor out whatever is left over. I have 7a squared and I have 3. So the correct answer would be A.